Hello, it's James from XRobots.co.uk. This is part 32 of my Iron Man Age of Ultron inspired Hulkbuster suit, which is actually a costume. This is built on a wooden frame which you can climb into, unlock all the joints and go for a walk around in. And when you're a bit bored, you can then basically lock up the joints and climb out and leave it standing there as it is now. So I've been putting panels on over the last few episodes. This has been quite a long build so far and we've still got quite a way to go. I've done quite a bit on the legs and I'm feeling a bit nervous that I won't be able to move in it if I keep boxing it in with panels. So today we're actually going to do a test drive and see what flexibility I need in the joints. So I already put the cod plate on last time and I need to check the clearance there with the thighs. So the problem I've got is that as I've built on this, it's got a bit heavier, so I need to check that. But also the knee latches are looking a bit spindly, which is quite bad, because if they fail, then the whole thing is going to fall over backwards. I need to also be able to check that I can effectively latch and unlatch those, and they're a bit fiddly at the moment. So as well as that and some of the other mechanical aspects, we've got various bits and pieces which pop open. We're going to have a look at some of the mechanics today. So first of all, we're going to turn this round and have a look in the back. This is what the back currently looks like, obviously substantially less finished. We've got a bit of a frame there on the back of the torso, but essentially not much else. I've put several mechanisms in to open bits and pieces at the back. But yeah, not a lot there. So let's have a closer look at those mechanisms. I put these pieces in which are going to open the back panels, and those will neatly slot into the gap that I made last time with these side panels. Inside here we've got snowboard bindings which lock my feet in place, which are pulled up by a strap, and then there is a release that pushes this back again, and that part works relatively well. The torso itself is just sat on top of the thighs, and that's just picked up at this level when I get into it, so that piece is okay. But the knee latches are what we really need to work on, which are down here. The knee latch itself is this piece, which puts a bolt through these two bits of wood. One is the thigh and one is the shin, and I've actually put a nut on the other side because I don't trust it not to pop out. But normally that wouldn't be there, and that's activated by a bicycle brake cord. I'm not even going to try and demo this at the moment because the suit will keel over backwards. It should only really be activated when you're wearing it and holding it up. But they are quite dodgy, hence the nut on the other side, and they don't really pop in and out properly, and it's really hard to align the holes, and they do actually have metal plates on. Don't know if you can just see that, but anyway, what we're going to do is take the torso and the top of the suit off. We'll have a closer look at these, and they're probably going to get a redesign so they work a bit better. Right, so that's the torso, which on its own isn't too heavy. Now I've taken the arms off. Actually feels alright, I think it'll be fine with the other things on, but let's have a look at those knee latches. Several people have asked how I'm going to transport the suit, and this is the answer. Obviously it all comes into lots of pieces so that it can be taken apart, and hopefully that the biggest piece is the torso, hopefully that fits through doorways, which I think it does. Here's the close-up on that latch. So now I've taken the nut off the inside. This is actually activated by the other end of this bicycle brake cord. So if I go and push this, it should pop out just about. There we go. So now the knee is free. And if I pull the end of this, it should pop back in. The only challenge is that it's rather loose, and eventually it will actually wiggle out if I'm not careful, and then the whole thing will fall over. The other one is slightly worse than that. So this whole arrangement isn't particularly satisfactory, and also this thing doesn't home. I need to put an end stop in so I can get it back in. So I'm going to redesign this. There's quite a lot of space now underneath this hip pod piece on the side to put a much more satisfactory mechanism, hopefully. The other thing I've noticed is since I've put in this back door mechanism, I now can't bend the leg very far because this piece of wood hits it, so we're going to have to cut this corner off so that the leg will bend fully. This is one of the reasons I've stopped to look at the mechanics now before I carry on putting on panels. I'm too lazy to take this to pieces to cut this off, so I'm just going to try and do it like this. There we go. Yep, that's much better. So here's one of the things that I've pulled out. It was literally an arm on a thing, and the inside of the bicycle brake cord gets pushed and pulled, and that just kind of pushed and pulled it away from a thing it was fixed to, so it went like that. Not very satisfactory. For anyone who missed the original start of the build, episodes 1 or 2 for this, I just wanted to show another feature, which was my flip over ankles. So this is the leg straight up. If I now go and bend that leg back, I can also bend it forward and leave it sitting there. So that is the bent leg position, and that works through having a hinged piece right at the bottom, which hinges over on a lump with some door hinges, which means that I can actually heel to toe walk but still keep a flat bottom and have an end stop, so I can essentially stand up stable on my toes with a bent leg. We're going to have a quick look at the parts that I'm planning to print for the new latch. They're not going to mean much till I actually assemble them. This is the main part, which is very similar to the old part, but it's a 4-bar link. So the bolt in the end, which is in the end of this long sticking out tongue piece, will stay more parallel with the hole, hopefully. I've also got this block, which doesn't look like much, but that's going to hold 2 bits of tubing. And then I've got a disc and a block with a hole in and a wedge. So this basically is going to form the mechanics, which will be pulled by strings to open and close the 4-bar link. But let's get that printed and we'll get it assembled and do a quick demo. Here are the parts in their vague assembly. So this is the 4-bar link with the wedge on, which does this. I've got the block with holes in, which is to shove some PTFE tubing through, which fits just snugly in there. And then I've got this piece, which is a pulley with a bolt on, and I've just used some normal M6 bolts that I picked up. So it's rather hard to explain how this fits together without actually showing it. I've already assembled one leg, so let's take a look. Okay, so here's my 4-bar link, but it's rather hidden behind the pulley there. So what actually happens is the bolt is right in the bottom there, and that is going straight through the wood and out the other side. And obviously this thing at the top is fixed to the top piece of wood. The bolt goes through the bottom piece of wood and actually latches into the top piece of wood, so it's kind of fixed between, which makes it a bit more stable. It was the other way round. And now basically what happens is, as this wheel turns, the bolt in the side, which was the extra bolt that's in there, pushes the 4-bar link away. So that pushes out and the bolt comes clear of the hole. And now this 4-bar link is sprung with this piece of bungee cord, and the wedge on the bottom, the white wedge, is actually locked against that bolt now. So you know, you can't push this in and it's locked in position. And then when we turn this back the other way, of course the bolt in the bottom comes here and the thing latches back in. And I've controlled this with 2 pieces of string which go through these 2 pieces of tubing. So these are right by my hip on each side. And of course if I pull one, it causes the knee to unlock. And if I pull the other one, it locks back again. I've just put the torso back on there so you can see these strings come out just to the side of my hips. So I can pull one to release, which slackens that knee, and then lock it back again. Obviously that doesn't happen until I get into the suit and I'm supporting the body. So I would be up here, having picked up the torso. Don't have the arms to grab onto at the moment, but there we go. And then I would release the knees, like so. So I need to put the proper snowboard boots on and give that a go in a minute. And that's relatched. And I can put the torso back down and I should be good. Right, let's have a go at walking in it. I've only made one change, which is to put more foam on top of the shoulders so that the torso is slightly higher, only about that much, which just gives me a bit more clearance in between the thighs, which I pick the torso up from. So let's have a go. Now without the arms it tends to fall forwards quite a bit, so I've got some additional clamps that just stop the torso falling forwards by itself, but with the arms on it balances quite well. So let's just put those feet in, there we go, so that's the height. I'm going to have to be quite careful that I don't hit the ceiling, which I probably will, and that's why I haven't got the arms on at the moment as well, because it makes it even wider, which is a real challenge for testing in here. So that's my snowboard bindings, and let's just grab the strings for unlocking my knees. Obviously I can extend those tubes to put the cords more conveniently, probably in front of me. There we go, so that was a bit easier than it was before. And then hopefully I can walk. I'm only ever really going to take small steps. I'm having some trouble there with the ceiling, but essentially that's me bending the knee, which works okay, and if I don't do anything too extreme, my cod plate remains attached, so I can bend one leg just about. And I should be able to use, if I don't hit the ceiling, that knee, that bend on the toe to push forward onto the other leg. So if I'm lucky and I get my balance right, I should be able to walk like this, which was the original plan, and I should be able to walk backwards by using that toe mechanism I showed you. So that doesn't work out too badly. I'm not planning on going too far in it, but it's okay for the quick demo. Most of the time it will probably stand there locked up. So I'll just lock my knees up, and I should be able to put the torso down, and I'll release my legs. There we go, that's the snowboard binding release. And I should be able to put the torso down. Yeah, you can climb out the back. Bit trapped by this wall now though. So it's worth noting at this stage that if I didn't have such a wide suit on, I'd be able to walk quite well. So here's a piece of footage from part 5 almost a year ago, where I didn't have all the stuff attached to the frame. And you can see there I'm walking not too bad front and backwards, but I am swinging quite a lot side to side. And now I just can't do that in the room due to the slope of the ceiling there. So hopefully at some point I'll take this to an exhibition hall or something and you'll be able to see me walking around in it, but for now it's fairly limited. So I'm fairly okay with that. I think it'll all work out okay, but now I've sorted out those knee joints and I can see how much the ankle flex is, and I can get in easily to test it. It's going to be much easier to build out the rest of the suit. So let's have a look at those arms. Right, here they are. So in the forearm we've got a motor which pulls a cord and will cause the hands to grip. On the back of the hand we've got a flip out weapons pod there with a servo in it, and I've already mounted an Arduino in each forearm. And then in the upper arm we've got this joystick which can slide up and down, so I can put my hand out wider and still reach the arm, and that's got 2 buttons on it. So we need to activate the motor, which is on the back here, with a pulley and that motor is going to hinge the forearm. So that's mechatronic from the shoulder down, or from the elbow down. And we also need to be able to activate this weapon and the one that's in the shoulder for the suit as well. So I was going to put additional buttons on, but I've actually had a much better idea. So I was playing around with an Arduino, as I tend to do. I've got an Arduino Uno here, which is the same as the one in the forearm. This is just a battery that's powering it. It's not currently attached to a PC. I've got 4 LEDs, each with their own resistor, which are wired to some digital outs, and I've got 2 press buttons just there. So at the moment, these buttons represent the joystick buttons, and the LEDs represent various different functions. So if I press and hold these buttons, we can turn that LED on, or we can turn that LED on. And that means we can drive the arm in each direction at the elbow. But if I only press them and let go, then they turn on the other LED. So we can use those to fire the weapons. So that's the press and hold. And that's the short press, which has to be less than half a second. So basically I've used the timer to see how long the button press is. If it's less than half a second, it turns on one LED. And if it's more, it holds the other one on as long as you hold the button down. So this is what it looks like in code for one button. The other button is down here, which is exactly the same. So what I've got here, basically, I'm using input pull-up, so the switches actually go to 0 when they're activated. So it checks to see if that button is activated, then it waits for half a second and checks again to see what it is. And based on its state, it will do one thing or it will do the other. So if the button is still activated, then it will do else, and that will move the arm. If it isn't activated, then it will fire the weapon trigger, which it does for half a second, and then sets it low again. What I did find is I needed to put this flag in, so if it does move the arm, it sets this flag to 1, and there's another nested if statement here to check if that flag is 1 or 0. And that's there so that basically when you let go of the button to move the arm, it doesn't fire the weapon because it meets both conditions. So I've got several types of connectors here which I need to wire in so that I can still take the suit apart. I've got these 9-way D-range connectors, which are just those 9-pin connectors, and those are going to wire basically the joystick and power down to the Arduino. So these go at the elbow so I can still get the elbow apart. And the other connectors I've got here are these quite large 11-pin connectors with lots of pins in. And basically there's going to be one of these on each arm at the shoulder connecting to the body, and one on each leg, so I can take lots of connections down. So there will be more controls that come up into the torso and back again, so that I can both activate the unibeam and the shoulder weapons from the hands, but I can also activate the hands from the Wi-Fi stroke smartphone control that's going to come in the future. Just printed some little holders there for the connectors so that I can mount one half on the joystick side, and obviously the other half will fit on like that, and that wire will run off and go down to the forearm. So in my arm I have a little 5-volt regulator board which takes 5 volts into that connector, and it takes 12 volts in the input of that regulator board from my LiPo, which will be on this connector somewhere up in the shoulder. On the connector I have multiple pins. I've got 3 wires coming back. One of those is for the shoulder cannon firing mechanism. The other 2 are to control the arm in each direction at the elbow. So for the motor at the back there, obviously when neither are high the motor will be off. And I've also got the pins going into this from the 2 joystick switches, which are basically pulled down. So the black wire going in here is ground, and the other 2 are the switches coming out. So those will go off into that connector. I'll then attach the Arduino, which is in the lower arm, and that will decide what to do. It will switch the servo in the forearm and send the other signals back on these wires to activate the rest of the arm. I've made up some wires here which I've actually fully populated all 9 pins, even though I haven't used them at the other end in case I need to, because there's probably going to be other functionality. So I've got black and red wires there for 5 volts going down to the Arduino, and a whole bunch of other wires for all the other functions. I've now rehung the arms, so right in there we can see the joystick with its wires and the connector at the top, and we've got this multi-stranded wire which has got plenty of slack on to come down to the elbow, which will then attach to all the ins and outs on the Arduino. Of course, the Arduino provides the logic, so that then connects down to the servo. There'll also be some sort of motor driver for this motor. Obviously, what I've realised is I need extra functionality, so I need a way to activate the gripper as well. So I think what I'll do is just build in some more logic, so when I press both joystick buttons together, that activates the gripper. Obviously, that'll be within half a second as well. So that gives me lots of functionality based on button combination and grip or click speed. So the other thing I need to consider, of course, is how I would open the helmet and open the flaps and fire the unibeam and things like that. But of course I can put some logic in so that when I press combinations of buttons on each arm for a long or short hold, then I can make that operate additional functionality, so we can actually get quite a lot out of our 2 switches in each arm. There is an option of having other buttons, of course, if I really need them. But you're going to have to wait for next time to see that functioning, when I think I'm going to start working on the forearms, trying to get all of this working and build some of those weapons in the weapons pods on the back of the arm. So don't forget to subscribe to my channel to check back for more updates on this project and other projects, and also check out my Patreon crowdfunding, which is how all of my projects get funded by my followers. You can get access to some exclusive rewards, including a live broadcast with me. That's all for now.